Okay, on problem number 4, and that's a complex number problem. And I would say that sometimes they get a little complicated, but let's take a look at it. And I'll go to the whiteboard to do that. And there's 2 of them to do, by the way. And they're asking me to, verify certain things about this. So let me write the first one down. All right, the first one is the absolute value of 1 over z is less than 2. And I want me to, kind of explain what's happening over here. What I want to claim over here, z, is a complex number of the form a plus bi, where a and b are real numbers, right? And this can be easily plotted, by the way. What I mean by that, you're going to see a graph. There's going to be a real part, and there's going to be an imaginary part over here. And then there'll be some point a, b in the plane. All right, let's write this down. So absolute value of 1, what's z going to be? A plus bi. This is less than 2. All right? So what do you do now? I guess you got to maybe rewrite a little bit. And I'm going to just simply say this is 1. The absolute value of 1 is 1. And then the absolute value of a plus bi. I want to go remind you what it is. The absolute value of z is the modulus, which is the square root of a squared plus b squared. All right, let's write that down. This will be 1 over the square root of a squared plus b squared less than 2. All right, I'm going to keep moving along and wonder what to do there. I'm going to just, they're positive numbers, so it's really kind of easy to deal with this over here. So a squared plus b squared. It's easy to get confused with inequalities, it really is. And this would be greater than, let's see, I'm doing reciprocals, right? Be greater than 2. All right? Oh, I'm not sorry. What am I saying? I'm sorry. I made a mistake there already. Doing reciprocals. You know what I should do? I should do the work, actually. So let's write this down. So I'm getting, this would be 1. Whoops. I got confused myself, by the way. This will be 1. This will be 2, the root of a squared plus b squared. I multiply both sides by a squared plus b squared. Then what are you going to do? And you're going to divide both sides by 2. You get 1/2, and you get this over here. All right? That's not so bad. So now what I got to do? I got to square both sides. And what do you get? You get 1/4 a squared plus b squared. All right, I'm thinking about this now, and I'm starting to think that this sort of reminds me of a circle. And let me talk about what I mean by that. If I look at this thing over here, it's a circle. This is the A, by the way, and this is the B. I'm going to say it's a circle like this over here. I'm not great at drawing a circle, by the way. And the circle is centered at the origin, so the center is 0, 0. And its radius is just 1/2. Now I got to start thinking about this. And someone says, what are you thinking about? I'm thinking about what the picture is. And I'm looking at this over here. I like to take test points, by the way. And one test point on the inside is 0, 0. It's an easy one to do. And if I just plug that in here, that's not true because 0 is not greater than 1/4. So what is it? It's everything outside the circle. And again, you take a test point there if you want. So that one's done. Now let's go to the next one. Next one's far more difficult. Let's write it down. And the next one is going to be, let's take a look at that. It's going to be the absolute value of z minus 1 over z plus 1 less than 2. And I'm going to say z is still the a plus bi. So let me write that down for you. So it's a plus bi minus 1, and then a plus bi plus 1. All right? I know this is the modulus. I'll write this over here. A plus bi minus 1. A plus bi plus 1. And I got to do the modules. Before I do that, I want to rewrite it a little bit differently. I'm going to say it's a minus 1. That's the real part. Plus bi. That's the imaginary part. And the bottom I'm getting a plus 1 plus bi. And I can put the modulus down now. So what do you get? Top, you get this. A minus 1 squared plus b squared. On bottom, what do you get? A plus 1 squared plus b squared is less than 2. By the way, what's nice about these numbers are positive numbers, so I can just, multiply both sides by the LCD. And what do you get over here? You get this. And you get this. I'm going to square both sides. And again, they're really nice things to square because they're both positive numbers, so it's really easy to do. You just get a minus 1 squared plus b squared. Here you get 4. Then you get a plus 1 squared, sorry about that, plus b squared. All right, let's keep working on this. And where it's going to go, who knows? You get a squared minus 2a plus 1 plus b squared. This is going to be 4. I'll go slow. A squared plus 2a plus 1 plus b squared. I got to still simplify, don't I? And again, I hope it becomes obvious over time what these things are. This is 4a squared plus 8a plus 4 plus b squared. And I'm going to try to rewrite that in a way that looks a little easier for me. So I'm going to take away a squared from both sides. You get 3a squared. I'm going to add 2a to both sides. That's going to be 10a. I'm going to subtract 1 from both sides. It's going to be plus 3. And I'm going to subtract b squared from both sides. It's going to be, you know what, this is 4b squared. Sorry about that. That's going to be 3b squared. And that equals 0. I'm trying to realize I got another circle on the hand, so let me write this down for you. I'm going to take away 3 from both sides. And you get 3a squared plus 10a plus 3b squared. I'm going to divide both sides by 3, and you get minus 1. You get a squared plus 10/3 of an a plus b squared. I'm going to complete the square by adding a number to both sides to make the a expression a perfect square, 10/3 of an a. Half that would be 5/3, so you're adding 25/9 to both sides. Let's do this over here. 25/9 minus 1 is 25/9 minus 9/9, which is 16/9. And this is going to be a perfect square. It's going to be a plus 5/3 squared plus b squared. Well, again, I'm seeing the circle. And the circle I'm looking at, this is circle, by the way. It's an inequality, but still a circle. The center is going to be minus 5/3, comma 0. And the radius is going to be 4/3. I'm going to draw a picture of this, just a rough picture. The center minus 5/3, 0. I'm going to say over here. The radius of 4/3. So I'm going to say it looks sort of like this over here. And this is a rough picture, by the way. All right, this is a circle. Now, by the way, I always like to take test points because the inequalities really do confuse me a great deal. And the test point I'm going to pick is this point over here, which is 0, 0. If you plug it in into the inequality, you get this over here. You get 5/3 squared plus 0. Well, this is 16/9, and 5/3 when you square it is 25/9. And 25/9 is bigger than 16/9, so I'm going to say it's everything on the outside of this circle. And we're done. Thank you.